স্যার তাহলে স্টার্ট করবো স্যার?
হ্যালো।
হ্যালো স্যার, বলছি স্টার্ট করবো তাহলে? হ্যাঁ। হ্যালো।
দিন।
So welcome to the webinar of Bidhan Chandra College. Today our special guest is Professor Molay Banerjee from IIT Kanpur. So he did his PhD from University of Calcutta. Then he served Presidency College and Scottish Church College in Calcutta. After that, he joined IIT Kanpur in the year 2008. Currently, he is a professor of Department of Mathematics and Statistics at IIT Kanpur. His research area are mathematical ecology, nonlinear dynamics, and spatio-temporal pattern formation. So, beside this, he is also associate editor for two special issues on COVID-19 modeling for the journals Mathematical Modeling of Natural Phenomena and Letters in Biomathematics. So now I request our Honorable Vice Principal Sir to address our chief guest. Sir.
Good afternoon, everybody. Respected President of the World Body, honorable person, honorable dignitaries, dear colleagues, beloved IQAC coordinator, convener of the convener. It is really a great pleasure and privilege present in national organized by the Department of Electronics in collaboration with IQAC. Being the head of the institute, congratulate the departments of mathematics and electronics, especially Dr. Ekut initiative organized the national webinar. First of all, I on behalf of the must welcome person Molay Banerjee, Department of Mathematics, IIT Kanpur.
It is really a great pleasure and privilege.
He have responded to our invitation despite its busy schedule. I convey my best for governing body, all members, all support, organize the national webinar. I do hope that our participants will a sound harvest from the day's that the day's interesting and interactive one. The survey of the day speech and respect. I do hope would find the minds of the teachers and thought. I wish firm success this webinar. Once again, thanks to
Molay sir. Sir, you can start now. No sir. Sir, we can see only you.
Now it is visible.
Yes, sir, it is visible.
Okay.
No, can, I think again, yes, it is visible.
Full screen, right?
PPT visible.
Yeah. Okay. Okay. Good afternoon, everybody, and thank you very much for this kind invitation talk. At the very beginning, that I tried my well best uh, the contents and accessible level such that who are not particularly from this area can understand what I am trying, and also at the same time, if anybody are there who are working in India and want to have some idea that what kind of search can be done in some ingredients will be there for them also. The main idea of talk is multi-scale modeling and irregular oscillation. The context of population dynamics I'm going to talk about, that was not yet the title of the talk, but actually I'm going to talk about in population. So my plan of talk is that first I'll give as well as well-known math from where I can derive criteria, what condition the oscillation the population. That's why first I put the name of the cycle of the cycle. Then I'll talk a little about the slow first time scale, why or how fast scale can and then I will multiple. So first of all, I want to give size most of the participants. These are different kind of sample of brain action that we can see. But at pictures carefully, and there is an edge from this. What I'm trying to say, that suppose talk about the and higher, you can understand find the example of at least one forest where the on for the land. It is expected some antelope or deer or guy or some other buffalo that can be available possible for the lion, as well as the right hand picture of a deer and a tiger. So tiger might have some other zebra and other animals. And on the right bottom of a polar bear, also uh, their source in terms of the variation of the fundamental. Precisely in winter, they have survived on one kind when the ocean then they cannot catch deep. And that's why at the same time try to survive on some other items, but during summer can have their more affordable food. But all these kind of education get their population. So one such example is well-known data, because we are working in ecology at the very beginning already have gone through the IB. That is the data for population density of hair and lynx that was collected for 100, and different possible models have been built up so far in order to capture dynamics. But the most is one, understand variation of the population, some sort of moderate as a predatory dynamic. But particularly, I don't sort of then consider as a rather I have to as a transient oscillation or some sort of irregular oscillation or oscillation with some sort of component. And the main goal is that I am not going to match with, but I will give some way out such that you can see as a end product of this talk, solution can capture kind of. But if you ask the question, how exactly regular oscillation problem? So, particularly what we can try to, there are some things, both the population are not staying with the advancement time. There is some clear-cut variation in the population. How kind of dynamic can be? Simplest one is the classical Fenwick-McCarthy. I'm not saying the model for rather model for wide class of consumer model, or N can consider this abbreviation and P can be considered as an abbreviation. Now, coupled nonlinear ordinary, what are the different components? Assume absent, then you can have this Rn. So this part actually describes the growth rate of resource, the absence. Once consumer coming into the picture, so their rate of capture derived by these terms, and consumption of resources by the consumer transferred the of the and here is the for the natural question might be coming to your mind, not for all of the parties, some of the parties not familiar with this kind of analysis. I'll give you in the next slide a description how kind of functional form can be. Now, what are the interpretation of different parameters? Here, the small r is called per capita for the day, or A is the carrying capacity. You can check that if absent, then this per capita positive per n A and it is negative. That's why it is called carrying capacity. That means the environment or resource can support their growth up to the level n, not beyond that. A is the attack or predator per unit time, H the handling time, and the conversion. Means whatever the amount of biomass or digested by the population, the entire amount is not directly converted to the growth in the biomass of the, rather only fraction of it converted to here. There are some about the energy budget, but I am not going. But the dimension quantity, and it always lies between 0 and 1, and it called the in. Now let us try to understand how functional response is coming in form. The idea is that some tables required to be and some assumptions required to be made in order to come out with. So let us consider 4 variables. N is the number of potential, the number of break hot teams, and T is the total time, that is the time window over which we are looking for that how many prey caught by the predator, and handling time for each prey. Handling time means starting from catch and then particular processes clubbed together labeled as a. Now before proceeding part or couple of I want to make a clear-cut statement here. Handling time plays a critical role in order to functional. A simple example is that sometimes it happen for certain interaction for one particular diet of may need more than one prey. Sometimes it can happen that one prey item shared by one, and that depends upon the body size under consideration, so many different things. But just for mathematics or confined within just now, h is the time for each day by the. Now what is the assumption behind construction of the assumptions? That number of victims, that means number of prey caught by within proportional to the number of potential. The number of potential prey, then number of V, that is one assumption. Second assumption is that the number of victims, that means number of prey caught, proportional to the searching. Fine. Here we talked about total time and TH, the handling for each prey. Now with this assumption, if now write down the, so then V coming out to be alpha times minus multiplied by N. N stands for number of victims proportional to number of potential, and this minus the searching. Why? Because V is the total number of prey caught, H the handling time for each prey, the total time spent for handling number. Therefore, we are left with minus as a searching. So, if we combine result and then alpha of variance, and then from here we solve for V, find V equal to alpha Tn by this one. And why I'm writing phi n? Because the total number of victims over and time in, therefore number of victims or number of prey caught per unit of time divided by T, an by 1 plus a. Little bit different parameterization. Now alpha is a and th by h, and hence in the previous h. So this is the story behind the choice of this. Now you might be wondering that this is the only function. No, there is plenty. So far as my knowledge goes, there are probably 91 functional, but some of them are listed. I already talked about type 2, other functional hyperbolic function, Ivy League functional response, Boolean type 3, non-monotonic functional 4 function. Apart from that, in order to talk with mediocre level, I do not consider the functional response upon. There are a couple of examples where functional solve the period density, because when there is a scarcity of availability of the or food item. So there might be some interference between operator will influence shape or rate and amount of got by. Just for simplicity are the example of responses in terms of prey density. Now, how that particular model can be realized, what kind of out of those? First of all, can try to non-dimensionalize model by integrals x, y. So instead of 6 parameter, now we are left parameters. And you know, there is no mathematical available far by which what you can do, you can try to find out somehow any solution for this. What is the form of the solution? Are equilibrium solution. Those are actually called equilibrium points. How those can be? The idea is that you can try to find out whether there and equal to 0 simultaneously. If it happens that for some positive value of x, y, that particular constant quantity y are the equilibrium solution because satisfies this equation. Once equal to constant equal to 0, right hand side is 0 by this equation. Therefore, it's first equation, and secondly, y dt is also equal to 0, and that particular xy as xy equal to 0 right hand side. So, what are such solutions? One solution that means equal to 0, y equal to solution of this equation. Then x equal to 1, y equal to 0 also a solution, and x star y star equal to 0 are also solutions. And now the solution P for which both x star and y star are positive, and for positivity that these parametric are simultaneous, and this positivity squared there is no meaning for population negative. Therefore, we need to ensure that some solution positive in order to make it ecologically, biologically. Now, with this system, what we can try to do, we can just try to understand how the solution, the visibility of this, and that tendency or that nature of the that means trajectories nearby some points can be obtained by studying the look. So how that can be done? Idea is that suppose star y star the solution, and now you are giving all perturbation around that particular. What is our goal? We are just in understand all perturbation, then and go with time, or it both you start time. Say star y star are stable because perturbation die out and trajectory will have a tendency to come back to the point x star y star, and therefore x star y star stability. Now, how that stability can be judged? On the left hand side, after differentiation, also constants having e dot b dot, and on the right hand side, you can just consider Taylor expansion. After the Taylor expansion, that this part is 0 because x star y star similarly of x y star, and you have first order term and higher order. Now, as we are considering small perturbation, the mathematical assumption is that second and higher orders of u can be neglected. Once you neglect, then you will have this type of, and then the standard theory of system of linear equation can just try to verify under what condition solution of these have a towards system, and that can be done very by demanding that two eigen of these have terms of the inputs of these matrices. So just for your information, what is A11? A11 is nothing but partial derivative of f x and evaluated and so on. A12 f del y, 1 del x, and del y evaluated. Now with this one, the stability condition demands that trace should determinant positive, and therefore eigenvalues like this. Now here I have mentioned one more thing, that is loss of monotony property. It's a new kind of idea in the context of technology is coming into the picture, just in order to understand the transient dynamics. What does it mean? Once we are talking about conditions in terms of these, but these conditions never tells us whether are real numbers or complex. Actually, once the discriminant becomes negative from positive, that is the point of loss of monotony. Why? Because the eigenvalues in solution trajectory monotonically converges. Not then state around for converging particular. And then what is Hopf bifurcation? Hopf bifurcation, that is the onset some prediction. Mathematics, what can be that once the true eigenvalues that sign from negative part positive part, that is the Hopf bifurcation. For that, we conditions are required to be. From here, you can clearly verify that if 1 plus equal to g, part is determinant, that means quantity is positive, therefore we have to, and if happens with respect to a particular parameter alpha involved with the model, then so instantaneously on one side it will be positive, on the other side the side where it is the other side where that is unstable, and what will happen that there will be of stability instead of a stable equilibrium point. We have a stable your Hopf bifurcation super critical. I am not going, but keep in mind all the times we cannot ensure that exists Hopf bifurcation attracting periodic cycle. There might be some situation where Hopf bifurcation have a unstable limit. Will remain positive, but there will be unstable surrounding, and these are the parametric criteria involved with attractor. 1 to 0 is always a point. 1 0 stable if condition, right? Otherwise it is, and each star once condition alpha greater than. So compare condition, clearly understand that existence some point x 1 0 is unstable, does not exist, then it is, and more precisely stable range, that means where alpha is greater than this one and less and otherwise unstable, and in particular when alpha less than threshold attractor, once alpha satisfies this condition, the global attractor, and once the stability lost, can have that means cycle surrounding global attractor. Fine, that means once stability lost, the limits surrounding global attractor of Rosenwig-McCarther model as we are considering, not a general statement, because that limit cycle might not be a global attractor. It can exist than one boundary or axial, some sort of, here the black curve is the plot of the curve, the plot of the curve vertical black line, plot of y equal to 0. And as there is no point of curves within positive quadrant, then there is no equilibrium point coexisting first quadrant, and all the trajectory are converging towards this axial attractor. Now, once they intersect, and you can see stable equilibrium, now all the trajectories are converging towards this global attractor. And if you look at the dynamics of this trajectory, starting from here towards left, then start downwards, again started towards right, after some converge to this point, and where started arising from monotone convergence to non-monotone, that is called loss of motion. Afterwards, it loses its, becomes unstable but surrounded by a stable limit. And from this flow diagram, you can understand cycle is always attracting nature. That means it attracts all the trajectories starting either inside or outside, except from these points, and all other points with first quadrant, not beyond the first. And then what will happen, or with the increase of the parameter, the limit, and you might have a, but you know that if you plot this one, you can see kind of oscillatory of the peak are of height like this one, because this is transient, but afterwards all the peaks are of height, that is a bit far from stability. And what the transient for, I just want in why or where this transient dynamics comes in. Transient dynamics comes in the way, suppose you are considering the solution starting different. So with this one, I'm considering x value, but I'm changing the y value. What will happen? The y value start from here, have start from 0.5, have this, start from 0.75, have this. You can see that depending upon the initial population, the fast appear at different time point. It's a blue curve, fast peak around t equal to 30, for red around 39, and for yellow close to equal to 50. But afterwards are appeared gap. Now from the transient, that there is a delay, the generation of the peak that is first appearing after the initial peak here, and this is called part of transient. And this is clear-cut explanation why this is called transient dynamics. The parameter values be close to certain bifurcation parameter, then case equilibrium point is shows some sort of behavior, but with gain magnitude. And if you go up to equal to 3000, part is, but if after the Hopf bifurcation, all amplitude there, and it will never converge to point, rather it will converge all amplitude. So these are called some sort of transient. For settling down to the attractor, shows a different time dynamic, longer time. That is why it is called transient. Now we can come to the idea of slow first time scale. What is the slow fast time? That the equation of the non-dimensional and sorry, the non-dimensional version of sometimes it happen that growth of the tree might be slower time compared to the growth of tree. Very simple example is autotroph herbivore interaction. In case of grass or some plant, that growth much faster compared to some of their consumer like cow, buffalo, uh, their that's why in order to have the of the more or less what we do produce times factor epsilon here such that alpha 1 will equal to epsilon times alpha and delta 1 is epsilon times, and then Chenwick McArthur model with multiple time scale come in particular format. And what is the effect of this epsilon on the resulting dynamic? Resulting dynamics is that on the left hand panel have the trajectory for epsilon equal to 1, but on the right hand panel you can see the trajectory for epsilon 0.1. So from this picture you can probably able to understand some point more or less there is no variation, but the solution trajectory and their approach towards the convergence of complete changed. Here, our naked eyes we cannot see further here one, and if you have a close app here we can't see, and also there is a size of the limit. So with epsilon equal to 1 have as the limit, but with epsilon equal to 0.1 have a different, and these are actually called fast branch, these are called slow branch, and but at the 1 to 4 can have some details about this dynamic. But the question is, what can happen if you consider epsilon much less? So one such example is that consider epsilon equal to 0.01, the size of the limit is much more smaller. But how the dynamics instead of a continuous here you can there is a fast growth, but there is a after this point there is a, and that's why it's called slow fast dynamic, because it from this value to in a very small time window, but it is coming down to this value over a comparatively longer range of time, and again it changes value for a small period of time. So again it is fast part, and again this is slow. That means change more or less same for a longer period of time compared to time window jump from this value to value 1. That's why it's called slow fast dynamic. And then finally you can see of epsilon equal to 0.01 have a complete different type of limit, and using Henichel's theorem you can prove there exists cycle where the solution converge at epsilon. Mathematically that is from mathematics, but ecologically there is such realistic example that where one species 100 times faster compared to the other, but 10 to even up to 50 faster growth is observed. In case you are not comparing the growth of a phytoplankton with the growth of tiger, in that case, of course, 100 times difference. So now we come to the concept of the main goal. That is, first I'll give some. I'll show you, and I hope from the picture you sense why we multi. So these are the different topics First, we have this. Then primary consumer, that is herbivore, survive on primary. Then third trophic level have carnivore survive on this particular primary. They are having fourth trophic level called tertiary consumers. They mostly survive on sometimes primary protein, sometimes on any one of these, or maybe two of two, and finally have this trophic level or apex. Mind that there are some other kind of classification. Ecology is not that much simple, but just as a representative thing, I have considered. Now, what are the different coming in different groups? Let's have a look at it. These are the examples of the autotrophs. So they are the primary or energy source. Then at the next, we are having this herbivore. So these are different herbivores, type on different types of autotroph combination. Then kind of or carnivore, but at a stage, you can just have a look that are the hard trophic level. That depending upon the choice and depending upon the food available, they most of the time survive. Just for example, sometimes survive on some of the. Also at the some time, they say or some other small animals actually survive the predation for than one trophic level. From there, also have one more idea: bird, animals, and particular forest you can have more than one. And another interesting point is that, for as my knowledge, that no practical example, either tiger or lion, the fungi particular example, but once they die, sometimes their dead body is by this or some others. There is some complexity, but the main message what I am trying to convey, that their dead for different scale, number one, and also consider any combination pairwise manner have one kind of growth, but if you combine them, different possible combination have complicated solution of different type of trophic levels over different forests or real life ecosystem. And this is an example that you have combination of prey, and then your one trophic level consists either 1 plus x or, and another trophic level consists of y1 and y2. Any of the autotroph you can consider one, and any of the herbivore you can consider y1 and y2. So that what can happen, that you can have one kind of cycle for this population, one and x2 y1, and another kind of oscillation kind of dynamics, one and y2. But if you combine, then you can find a complete different type of oscillation. And this is the example. 2 is the oscillatory dynamics between y1 y1. Black is oscillatory dynamics and y2, and magenta color card the oscillatory dynamics have by summing up x1 and y1 y2. But just in order to make them with this comparative frame, such that upon adding more components here, won't need larger and larger. What we can do in order to have it a reasonable way out, that okay, the same can be embedded, and only thing to understand whether their periodicity are same or they are different, and you can clearly there is a difference in the time scale or oscillator dynamics. But the point is that here now slow first times. Just for example, for one resource consumer, there is a difference in times. For other, there is difference. What will happen? Just for example, one population following that curve, another population following this curve, their combination produce complete kind of dynamics, neither oscillatory nor chaotic, rather it is complex. Next, what you can consider that okay, both of them actually relies on first time, or they are hit with first time. Consider this kind of situation. The next question is that epsilon 1 equal to epsilon 2 or not, and depending upon this answer, have complete different. So this is the case where you can epsilon, there is some sort of deformation, this curve also some deformation, back curve, and idea is that there you some sort of regularity now compared to earlier picture. I have shown that there was epsilon was present was 0, but now instead of 0, both of them are non-zero, not equal. Then you have much more as you. But in reality, what happens? What happens is that a particular realistic environment or open ecosystem have a combination of multiple kind of acting forces. And if you combine them all together, complete variety of pictures and end product one. But the question is how it will come out. I will clear cut represent. Suppose your x1 y1, that one follows kind of. Now if of the prey population and you incorporate that graph, suppose it's so it's actually performing or showing some rapid oscillation compared to, and in this way, on adding more and more component that you can for the entire ecosystem, then you can have some different kind of oscillator, and they are taking for different time scale. Third species, fourth species now into, and finally, and now get their combination time, that is for both source consumer kind of complex. And if you are interested, you can verify like chaotic, but this is not at all chaotic, because the simple criteria or fundamental criteria required to be for a chaotic oscillation, say small perturbation or initial condition, trajectory will be nearby, and hence the question of chaotic dynamics can be explored, and this is a emerging area on which I am interested. And if you are interested, that will be the success of my talk. But this is quite like chaotic, but actually chaotic result of multiple time scale dynamics. Now, how more real kind of model develop? I should not take much more time on this one. The idea is that you can think about that there are first topic level and two, such that for the nutrients they compete themselves, and also consumer have access to both of them. Complicated. If you are interested, you can try to explore this one, but mathematical analysis is quite involved, so I am not going into the details, just some sort of representation. Then within the simple multi-step model I have mentioned, the question is that how little bit of complexity can be added. Complexity can be added in a way that now you can consider are now depending upon x1 and so that means their concentration lies below some, then there might not be competition for having access. But if there is a threshold above competition, such kind of phenomena can be taken account with your modeling approach in order to capture the complexity. And of course, can multidimensional in order to have a more realistic picture or more realistic mathematical modeling for ecological systems. Now, this is the last slide for my talk. Apart from the that most of the time we are familiar, people who are working in understand it's called first tropic level or prey. Why is called, and this is called super predator or top predator, such that Y survives only on A and G survives on Y. But in reality, what happens that X consists of more than one species, Y consists of more than one species, and Z is also how it like. Suppose you have at the first topic level, at the second topic level, and two third topic level, just as an example. And these are some complicated, little bit complicated, not too much complicated work structure describe what are the difference and what we just consider version of model as this one of considered complete or complicated. Study this one and capture much more realistic scenario. And of course, the last but one slide I did not mention the variation of the time scale also can incorporate some slow fast time, all this action also. That means grows little bit slower compared to this one, much slower compared to this one, but little slower all this that will quite complicated, but that is actually the real picture of multi-step modeling. What is the take-home message? That reality is much more complex, and we understand those mathematical modeling. There are some references, papers. If you want, you have a look. Different kind of dynamical modeling approach. Understand the most realistic logical, and these papers by Rinaldi much in order to understand that how so fast time comes in, and whatever I talked about can be found our, and these are my collaborators and done some part of the work and working no problem.
Thank you, sir, for your nice presentation. Now we switch into question answer session because it is ready for. Hello.
Hello, yeah, I'm here.
Okay, sir. So, please, participant, please drop your question in the Google Meet chat box or YouTube chat box. Any question? Sir, we are waiting for the questions. Sir, just a few minutes.
Okay.
Hello.
Oh yes.
Hello.
Yes.
I am Manus Ghosh from Sirampur College.
Yeah. Yeah.
I have joined here for my peripheral interest. Actually, uh, my subject is not your modeling or
Okay.
for dynamical systems, but I have a little bit query regarding
Yeah.
your talk.
Yeah.
Sir, first of all, let me congratulate you for your nice presentation.
Thank you.
Uh,
Thank you.
uh, your speech based on, so far I understand, which is based on two assumptions, some
Yeah.
basic assumptions.
Yes.
So, humble question is, what is the basis of your first assumption? I mean to say, uh, does this assumption have any physical interpretation? Where we have made the assumption that potential play is directly proportional to the some sort of play or something like
Okay. Actually, this is a very good question. Depending upon that number of victims proportional to number of potential they have polling type to, if not they need to search, then consider other kind of. So whatever assumption, those assumption dive, probably you can recall that I already already talked about that there is one functional, and also you should admit that with time I can't all the functional happens that creator or consumer search for, say, just for example, the aquatic environment, when large some group of small fish or some other kind of species, there are different kind of interactions. So in that sense, simplistic assumption valid just for presentation purpose, but in reality you are absolutely correct that there are different kind of interaction and searching process and species are concerned. Depending upon that we can come out with different kind of functional.
that. Thank you, sir.
Sir, there is one more question.
Yeah.
Uh, can this model is useful to understand the COVID-19 kinetics?
This model is at all for this one ecological model
This question
for
comes
COVID
from the
19.
YouTube, sir.
You need to consider the epidemic model. Epidemic model uh, is close to this, but not exactly this, because there is no resource consumer kind of that.
Uh, Thank you, sir. I think there are no questions more. So thank you, sir, for your nice presentation. And one more thing, sir.